Hi, in this video we are going to study Rutherford's experiment or discovery of nucleus. Now why Rutherford did that experiment, or we can say why we are studying this experiment, is very important. Because at that time it was known that there are three particles in atom: electrons, protons and neutrons. Electrons are negatively charged, protons are positively charged and neutrons are neutral. So Rutherford did that experiment to know how they are arranged in an atom. So if there are things in a room, we would like to know how they are arranged, right? So Rutherford, out of curiosity, wanted to know how electrons, protons and neutrons are arranged in an atom. So what he did, now if we have some area which is not visible to us with naked eyes, and we want to know that how the things are arranged in it, how it's going to, what we would like to do is, we would like to throw things in that area and then we would see our things thrown. And from those things we are going to get conclusions about the space inside. So same thing Rutherford did. He decided to throw alpha particles in thin gold foil, and he did this experiment in vacuum because he didn't want any interference of other particles in the experiment. So he wanted to know the arrangement of electrons, protons and neutrons in gold atom with the help of alpha particles. Now what is alpha particles? In normal language, I will say two protons with two neutrons that are similar to helium-4 nucleus. These are represented with this icon. So what Rutherford did, he took a gold thin foil in vacuum, he threw alpha rays on it. Now, as you know that alpha rays are thrown on gold foil. If any one thing is thrown on the other thing, what can be the consequence? If there will be empty space, it will be empty space. The alpha particles will move ineffectively. If there will be big, huge or a great volume of massed items in the path, they will get bounced back. Or if there will be minute little particles in comparison to the alpha particle, then alpha particle will get deviated from its path a little bit. This is what can happen. So the same thing happened here. But what he observed was the amount of rays which were passing without any deviation, amount of rays which passed with a little deviation, and amount of rays which passed with maximum deviation. So what he observed, let's see. He noticed that the images can be, he noticed, as you can see on the image, that when the alpha particles are thrown on the thin gold foil, most of the alpha rays are going undeviated from the path. This was his observation. And few were deviated a little bit from their path. And very few were bounced back. So from this observation of the experiment, what can we conclude? As a normal human, what conclusion you can say? That if you are passing through a path which you don't know what you are going to get in front, and if you close your eyes and you walk on a road, if you pass the path without any hurdle, that means you were not deviated. You passed it with ease. That means there was no obstacle. So that means for maximum area of the gold atom did not have any obstacle for the alpha particles. So that means most of the atom of the gold foil was empty. There was nothing to cause hurdle in the alpha particles' path. And few were turned by their path. That means there is something that can turn the alpha particles from their path, but that is not spreaded all over the atom. Those are available in the atom in specific areas only, because only in specific areas the alpha particles get deviated, and very few were turned back. That means whatever is that thing which deviates the alpha particles is very small in size. That is not a big obstacle that will deviate large number of alpha particles. It is a small thing which is going to affect few alpha particles which are going to face it on up front. So these were a few observations, and what we can conclude from it. For concluding with it, we can say, so the observations told us most of the alpha particles passed straight through the gold foil. Few particles were deflected through small angle and very few were deflected through larger angle. So what can we conclude? If most of them are passing straight, that means there is a lot of empty space in it. Right? We can see here in the diagram. And if few are deflected, that means there are small portions of heavy mass objects available in the atom that can deflect it. And very few are deflected by larger angle. That means whatever thing which is deflecting them is very small in size, because only few alpha particles get them straight in their path. So how can we conclude that there is nucleus in everything? We got to know that is something. How we can conclude is like, if alpha particles are getting diverted, that means they are diverted by heavy mass object. Now in atom there are only three objects: protons, neutrons and electrons. Now out of these three, you can see on the screen that mass of protons and neutrons is big, very big in comparison to electrons. So that means the heavy mass particles, protons and neutrons, in comparison to electrons, are concentrated at particular positions in an atom in comparison to electrons. So he concluded that protons and neutrons are together in an atom, forming a small but a very heavy mass object in the atom, so that it can strike with alpha particles and deviate their path. So that is how we said that there is concentrated in a tiny volume. Sorry, we don't say, but Rutherford said that there is concentration of matter in a tiny volume situated at the atom center, the atomic nucleus, which he gave the name as nucleus. The atomic nucleus is small, dense region consisting of protons and neutrons at the center of an atom, and electrons are spread all around it. Thank you.